Okay.
Assalamu alaikum.
Walaikum salam, madam.
Good day, doctor. Thank you for this excellent session. Actually, I was looking at the what do you call them? Uh, the correlation coefficient mean absolute error, root mean square error. So, for example, the correlation coefficient, we know we need it to be very high. The root mean square error should be low. And what about the relative absolute error? What range will you be looking at them, or sometimes you don't look at them if they are not part of your the parameters that you'll be using to test your model?
Okay, thank you very much for that. Well, actually, in regression, this regression problem. In regression problem, the most common performance measure, there are several performance measures. So one is to look at work that has been done in that area. In machine learning, you need to compare your work with earlier works. So check out the earlier published work in that area, see what are the performance measures they use. Then you are going to extract those same performance measure from your result here. So mostly people consider correlation coefficient very, very important, because this is a measure of how close or how correlated your prediction is to the actual value given. You can plot it in a line, you see the way they flow. See, if one is flowing up, the other also flowing up. That shows that even if you are not predicting exact number, but you are predicting following the same pattern. This is very, very important. Sometimes we draw a scatter plot to show our result, to demonstrate that, we are getting very close to the actual result. In this case, this is 99.67. That is really very close. And you can see the root mean square error. Root mean square error is a very popular performance measure for regression problem, because what it does is it takes the absolute difference between your prediction and the actual value given. Maybe the output, maybe the first output is 21. Yeah, maybe the first output is 21. Maybe you predicted a particular normal absentee for someone is predicted to be 23 hours. Meanwhile, the actual given was maybe 24. So root mean square error will try to find the difference between 24 and 23. Then what's the difference? That's one, scale it. And then they're going to do it for all your predictions. Maybe you have like 30% of the data set. 741 data, take 30%. It will do it for all those values you have predicted, and then find the square root. That is root mean square error. It has its own fantastic interpretation depending on the problem we are actually solving. However, so these two, they are very popular, mostly always occurring in most regression problems. However, you see some regression problem whereby it is established, they like to look at relative absolute error. It has its own interpretation. We have root relative squared error, and then the mean absolute error. We have seen some data, some paper, some area whereby they want you to relate all of them. Then you have to put all of them there. In fact, there are some areas, for example, in software engineering effort prediction, they have special type of performance measure. After you got these numbers, then there's a formula you have to use to calculate some things for them. This is what they use in their own literature. We have to go by their own literature to make your work valid. Otherwise, you can't compare your work with someone who already worked in this area and possibly got it published in a very reputable journal. Then you need to follow that pattern so that you can compare your work to be able to see what you have gotten. However, it is flexible. So there are very common ones like correlation coefficient, root mean square error, very, very common. But then that doesn't mean in some areas also, they do consider relative absolute error. But the one that is so common is correlation coefficient and root mean square error, because when there's a change, you can quickly see the change, because it is root mean square error. Take the absolute difference between your prediction and the original value, square it, and then take a square root of the sum of everything. So you have look at it. The one that is relevant to you, you pick it. The one that is not relevant to you, you discard it. Hope I answer your question.
Yes, doctor. One more thing is, okay, like the coefficient of correlation, I need it to be high, like close to 99. The root mean square error, I need it to be kind of as low as it could be. So what about the relative absolute error? I think they should also be low, right? Relative absolute error, maybe.
Anything that has to do with error, the only thing that needs to be big here is the correlation coefficient. You get the point? Because it shows the correlation to the actual. So others, anything with error, of course, error need to be as small as possible. Yeah. It has to be as small as possible. Yeah.
Thank you. Thank you very much.
Barakallahu Fik. And you have to indicate it. That's why in the description of your work, you have to describe the performance measure you are going to use and how it should be interpreted. The higher the correlation coefficient, the better. The lower the root mean square error, the better. You have to make it very clear so that you don't just say, okay, this method is better than this method. Because based on what you have defined earlier, okay, people can understand that, okay, this is how we judge what we have done. So, I think we have another person reaching out. Mr. Hakim.
I have a question regarding the normalization of the data, which is one of the data preprocessing that we can do. I found that, or my observation is that in WEKA, it's like it's an inbuilt feature, because, for instance, if you go to the GUI for WEKA, if you run any of the classifier, you can already see that normalization is pre-selected. So wouldn't it, I mean, if we do our normalization before going into WEKA, will that not be like doing double normalization? For instance, you can just go to any of the landing page for the classifiers, and then you see this normalization there.
Okay.
Yeah, so will that affect our data? For instance, I normalize my data, and then I did not realize that this normalization is already pre-selected in WEKA.
Okay.
Yeah, will it affect my results, or it doesn't have any?
Okay, thank you very much. So for sure, one, that is if somebody knows that in the platform someone is using, like WEKA, do have pre-selection of normalization, then in that case, there's no need for someone to actually do it. Even in Python also, you have some application, you have some codes that already input their automatically try to pre-normalize the data, but we need to be sure once it has been, you know that it's going to do it, then there's no need to repeat it, because repeating it is maybe a little bit waste of time. And also once you have to normalize, because whatever you report, you have to make sure that whatever you report is what has been done. Otherwise, someone will pick up the data set, he will not do he will do normalization only one time. Meanwhile, you have done it 2 times because WEKA did one and you also did another one. So there is no actually need to do that, except if someone actually tried it and found out that if I do normalization first time, WEKA did it one, and then I also carry out my own normalization. And I noticed that if I allow the normalization of WEKA only, it doesn't get better result like when I did my own normalization, and even though WEKA does it again. Perhaps WEKA is using another method because there are so many methods of normalization. In that case, we have to find out what is the kind of normalization that WEKA is using. Then you have to document it. If that's the only way that gives you your better result, it falls under what we call a data engineering. Your data, going back to your data and try to do something about your data. You normalize it. After you normalize it, we can also use another normalization. Well, when you uncheck that WEKA normalization, using your own normalization alone, you get a lower performance. But when you allow WEKA to do it again, you get better performance. So in that case, there's no issue normalizing it 2 times. You are just converting the data, but you need to document it in your work. Okay, I use this normalization plus another normalization. That is double normalization. There's no harm in that. You are playing with your data set. There's no harm in that. But just make sure you document whatever pre-processing has been done on your data, either by you or by WEKA, so that the next researcher or someone want to work on after your work should be able to know what you have done and should be able to reproduce your results. I hope that clarifies.
Yeah. Jazakumullah khairan.
Barakallahu feek.
Second question, sir, is in when we are trying to optimize the hyperparameters, for instance, in SVM.
Okay.
For instance, if we choose like a polykernel, I found that sometimes if you also go into the exponents of the polykernel, they also affect the results. So will these exponents also be regarded as part of the hyperparameters, or they are just like ordinary parameters?
Okay, thank you very much. Thank you. Yeah. Sometimes, yeah, there are some parameter, they are hyperparameters, but like kernels and hyperparameter. But those kernels, because they are equation on their own, they also have their own parameter. So it's they are indirectly hyperparameter, actually. Yeah. Some of them sometimes will have very little effect, but sometimes they have very huge difference. So it depends on the data set. So they are not categorically hyperparameter, but it's like if something is an hyperparameter, the parameter of that hyperparameter is an indirect hyperparameter because it affects the modeling directly. The hyperparameter is any parameter that affects the algorithm directly. So hyperparameter, like polynomial or any other kernel, has other parameters on their own. So it's an indirect hyperparameter. We can also consider them as hyperparameter, though under those subparameters. Hope that is clear.
No, Jazakumullah.
Barakallahu fi. I think we have Mr. Abubakar.
Assalamu alaikum wa rahmatullah.
Wa alaikum assalam wa rahmatullahi wa barakatuh.
Thank you very much, brother.
Welcome.
My question is more like a request for an advice. So as a beginner in machine learning,
yeah,
what aspect will Prof advise me to perfect such that everything will become easier for me to follow?
Okay. Yeah. If you just joining us, I presume it depends on your area. So the first thing is to have a general introduction to machine learning. So we do. I'm not sure if you're ready. Are you on the platform? We have WhatsApp group. Are you in the group?
No, I'm not on the group yet.
Okay, so you can provide your details. So you can provide your detail in the chat. So our admin is not around; it's on a trip. So I think Dr. Mujisola, are you there?
Yes, I'm here.
Okay, thank you very much. You can send your details to Dr. Mujisola. He will help us get your number, your mobile number for WhatsApp. And, so and your full name. He will help us get the data, and they will pass it across to the admin who add you to the WhatsApp group. So once we are in the group, then we will also send. We have an introductory video we usually recommend for people who just join to watch. When you watch those introductory videos, that will put you, hopefully, inshallah, on a very good starting point. So where you have a general understanding. So then you are going to have a couple of other videos being referred to. And then I want to believe it's very straightforward, and anybody can easily catch up with whatever we have done in the past, okay? So provide your details to Dr. Mujisola there. So you will pass it across to the admin who will help us add you to the forum, so that then we will send information on those early videos that is good for you to watch at the beginning, and then you can follow with other related videos on how to go. Now, on how to go about getting started with machine learning. So you are welcome. So, and we wish you all the best. So is that all about your question, Mr. Abubakar?
No.
Okay, thank you very much. Yeah. Now, before we go, I think the last we have a question here. He said, my question is, let us say, for instance, an organization meet me and say, please, most of my workers normally come late to work. Can you please help us solve this problem using machine learning? So, yeah, Yeah, you can use exactly what we have just described. It's a very, very interesting data. You can see it. You can pick the data set and use it to request that company to get some information that are in this data, those features. Especially those features that when you remove other unnecessary features, those ones that made us to get like 99%, those are features that are very relevant to this kind of problem. But then it's good to use data set from that same environment. However, there's no harm in trying using this data set from another country. Use it first, and then let them provide features and then answer it. And maybe sometimes it works, since it is a matter of if the features are also relevant, they are related together. It's not an issue of that is specific to a particular region. Then sometimes you can use data from another region to develop a model to be used in another region. But when it has to do with special attributes that are peculiar to different places, then it might not work. But then there's no harm in trying. So we can have the data so you can do that. Yeah. So you do it the same way. Once you train your model, let me show you in WEKA what you do. Once you train your model, we have trained our model now. We got 99%. So this model looks a little bit reliable. What you need to do now is to provide an Excel file. If you want to use WEKA, it is free. The company can use it, anybody can use it. So in that case, you just go back to the Excel file we have used earlier. This is absenteeism. Now you create a new file with all these titles. You can remove those ones that are not good, those features we have removed. So those ones that are good features, identify, now provide those information. Okay, you can say ID is gone. Reason for absent, provide the reason, or maybe this one reason have gone, month has gone. I remember age was very important. Yeah, provide the age of the person, provide the workload, provide the each targets. This is going to be the only guy in this file. All these ones are gone because we want to use it for your new stuff now. So let's say we have only one. This is the only guy here. We want to check this guy. After we have built the model, let's assume this is the new staff from your company now. So we want to test. You save it, and then you get to WEKA here and say, okay, I've trained my model is performing well. Now I want to check for someone if it's going to be this or what's going to be. Is it going to be absent? How many? What's going to be the number of time that is going to be absent? How many hours? So you're going to use the supply test set. Supply test set. So here you're going to select, you pick up the data now. The data we just provided here in the Excel, and then you're going to run it, and that is how you can use Excel in such real-life scenario. So yeah. That is how I hope I answer your question. Yeah. And if the company then later want to really develop a standalone application, then they have to look for programmers who write program for them, either using MATLAB, Python, or whatever other application that they want to use to deploy. But by the time they are going to do that, they can also use WEKA to check and predict. So, if somebody is going to be absent, how many hours is going to be absent? So this can be done successfully in WEKA. So I believe those are the questions we have for the day. Thank you all. Okay, Mr. Ben Onoja, you raise up your hand. Mr. Ben?
Yes, sir.
Okay.
Thanks, Prof, for number, sir. Thanks, Prof, for the wonderful lecture. I want to ask a question. Okay. All these features that you have mentioned,
yeah.
If an MD or CEO is to use it to ask his staff about those features, will the staff, knowing that it may be detrimental to him, be willing to give those information that will be useful to the company against him?
Okay, thank you very much. Yeah, these are the
Thank you,
social
Prof.
aspects of these are the social implications of AI and the like. So, well, if you look at some of those information, they are basic information that someone can easily get actually. So let's take for example, yeah, this basic information. Somebody, let's say someone has been absent before. The manager has the right to know why someone has been absent before. You get the point now. Okay, so he will have provided the reason. So it's not something you can hide. Except if the person lied, then the machine learning algorithm might be confused. The modeling also will not be correct. You know, some people, they are absent, they get wrong, they give wrong reason because they felt that if I give the correct reason, maybe the manager will be very mad at him or her. Then they decide to, those can affect the modeling we're actually trying to get. So for sure, sometimes some of the features, there are those you can get easily. Sometimes also there are those that you cannot get. Yeah, you don't want to get some very sensitive information from people, then we try to build the model that can avoid such features actually. See, if a company knows that, okay, if I use this feature, people might not answer me. Okay, we can try to build the model using other features that people might be even willing to give you. For example, weight. If you look at even the feature selection we did briefly here, you can see that under the select attribute, height is even having very high correlation. Son, maybe as a son, as the case may be, even age. So social drinker, and this might be difficult to get. I don't know how you're going to know someone is a drinker. Transportation expense. Maybe the company can ask the staff, how much do you spend on daily basis on your transportation? Of course, people can decide not to be very maybe sincere with this, thinking that the company want to give me my money. People might escalate, might increase it, or what do we? They might not give the accurate value. But then, so there are some attributes that are there that if we feel that we might not be able to get some attribute, we rebuild the model using attribute that will be easier to get the features. This is actually what we do to solve such a problem. If after we build the model, the owner say, oh, we are having problem getting this information from our staffs, what can we do? No problem. We try to use feature that everybody will be willing, or they can even get it from your file as a staff easily. Actually, we prefer those kind of features that the company can easily get. And then we can use it to model who is likely going to be absent and who is likely going to be present at work. So, thank you. So, I think there's one other question. Alayinka Yusuf?
Yeah, thank you very much, Prof.
You are welcome, sir.
I was actually going to contribute to the last question that you responded to.
Oh.
That from what you have told us in the past, what we have learned from you in the past,
Yeah.
Machine learning model are data driven.
Yeah.
So the company, would have had those data in different formats, which could be aggregated together. For instance, the basic biodata information about, the height, the weight, the health record, the BMI could have been available. And like you mentioned, if someone comes late, for instance, the company will have also asked, why did you come late? So the final thing we downloaded from Kaggle might not just be a single data straightforwardly. It could have been aggregated from different sources that are available to generate that particular data set. So it also brought to mind again, if someone wants to engage me to get this, I would have to tell the company or the management, these are the kind of information that you must provide for me. And it is not a must to let your people know that you have such a thing in mind. So just be getting the information based on individual. So all of these can now be aggregated together to get the kind of data set that we found in Kaggle, which we'll now use to eventually to predict whether someone would fall into such or not in future.
Thank you very much. That's very, very nice analysis to the question. Yeah. So that is how it is. And if peradventure, so anything happens to still be very difficult to get, like I said, we can always try to train our model by avoiding such controversial questions. Sometimes some questions really might be very controversial, or people have the right to say, no, I don't want to answer. And those questions sometimes are those that are very, very powerful in predicting. So in that case, we have to find a way of doing it. They all fall under what we call here. We can see the feature engineering. Sometimes we might use 2-3 other features to generate a very powerful features, depending on the problem we are solving. If we're having a problem getting a specific feature, when we look into some other feature that might house or have information that could help us to get those features we are not able to get. So this is called feature engineering, generating appropriate feature, combining features together to make better features, or as the case may be. So thank you very much all for the attendance, the contribution, and then so thank you very much and wish you all the best. So hopefully we meet again next week. Thank you very much.
Bro.
Assalamu alaikum. You're all welcome. Have a nice day ahead. Thank you.
Bye.